On the workstation is an example of a typical water quality workflow or analysis. In this video, I'm going to go through how to go about creating and analyzing your data using this typical workflow. I'm going to start by importing the data from a flat file format. So I've dragged the import from file toolbox onto the workstation. I'm going to double click on it to run it. So in this example, we're going to use batch loading and joining because I'm going to bring in multiple data files. So I'm going to click load, and here we have 2 months worth of SON data. So I'm going to highlight the first CSV file and then hold down the shift button and select the second record. So now we have 2 months of data, and when we bring this into AQUARIUS, AQUARIUS will batch load and join those two signals. So I'm going to click open, and that provokes the time series import wizard. So this is a 4-step process, and through this 4-step process we'll also build a configuration file that we can use for subsequent imports. Here's a list of all the different types of data types that we can bring in to AQUARIUS. This data is time series data, but we can bring in data that's discrete samples, rating point measurements, all the way down to a flat file or a document. I'm going to hit next. So in this step we tell AQUARIUS how our data is set up. Here we have our data starting on row 3, so we'll start our import of the raw data at that point. We can also discard not a number flags that come off the sensor, or we can discard characters that occur, say quotation marks around our double date timestamp. We can also bring in other types of delimited files, like a fixed width file type. So when I hit next, we have step 3 here. We're going to set up what our date timestamp format is. So we can select from pre-existing formats, including Julian date timestamps or diurnal minutes and hours. Exit out of here, or we can manually enter in those values. So here my data is set up as month, day, year format. So I'm going to enter that in as month, day, and 4-digit year. Our next column is our timestamp, and that's set up as hours and minutes. So I'm going to, as you can see, I have our hour and minute stamps in capitals because AQUARIUS is case sensitive. So we have next all of the columns of water quality parameters. We can choose to import any of these parameters, or we can skip them as well. So if we don't want to bring in our millivolt data or battery data, we can skip that. So I'm going to hit next here, and in this step we save that entire process as a configuration file. So I'm going to hit finish here. And now we have that data as output ports that we can wire onto other toolboxes. So I'm going to delete the parameters that I'm not interested in importing, but you can bring all of them in, and there'll be multiple outputs on this toolbox. So I'm going to hit done. Next, we're going to bring that data into a threshold flagging toolbox. So I'm going to bring that onto the workstation here, and then wire it back onto the original time series. So I'm going to double click on threshold flagging. There's a couple different flagging methods in here that we can use. We could use threshold based flagging, where we flag any of the values that are above or below a certain threshold, or we can use rate of change based flagging, and this is where we set our unit time, and we can calculate any of those values that fall above or below a certain rate of change over that time interval. So I'm going to add a rule here. So the relationship is flag any value greater than a threshold of 100 NTUs over an hour period. So I'm going to set that flag code to 1, and I can change the color as well and hit OK. Now I'm going to run that. And hit OK. And now our output is that flag signal. So I can quick view that flags. Here's our quick view toolbox. We just have to call up all the flag values. So this is flagging the values that had a greater than 100 NTU rate of change over an hour period. So that we can use to justify where we set this threshold boundary. I'm going to actually modify that rule and add an additional rule. So I'm going to ask for greater than 50 NTU and I'll flag that as a 2. So I'll hit that OK. Run that and hit OK again. And now we'll quick view that again and see the results of both of those flags. So again, we'll call up our flags here. So here we can see that there's a bit more information as well as to other data points that we might want to remove. So I'm going to set my threshold or upper threshold trimming toolbox to about 400 NTU based on the flagging results. So I'm going to bring over a signal trimming toolbox. So that's under data pre-processing. And then I'm going to wire that across again. So I'll set my upper limit for 400 NTUs, apply that, and hit run. And we can also interpolate between any of the gaps that we create, or we can do that in the data correction toolbox, which we'll show you next. So I'm going to hit OK. And now we have our flagged and corrected signal. I'm going to bring that into a data correction toolbox in order to view all of those changes. So I'm going to wire that back. Double click on data correction. And so here we have a couple different things that are happening. We have the flagging results that we saw earlier, showing which data points were greater than 100 NTUs over an hour period. We also have the raw and the corrected signal. And then down here we have a correction history manager, and this documents all of the changes that we make to the data as it passes from toolbox to toolbox. We can't actually alter the raw signal, so we have 2 copies of the data showing here. We have the raw and the corrected signal. So at any time we can change back or revert back to the raw signal. So I'm going to go in and I'm going to use the flags here to help guide my corrections. So we see here that there's one dip in our turbidity reading here. So if I want to correct for that outlier, I can flag that one location, and that's using the mark region tool here. And then next I'll go and I'll hit delete region. So now this is linked to our logging name here, and we can say delete region due to outlier. So I can click OK, and now that's logged in the correction history manager. When we export this data, we'll have the raw and the corrected signal, and we'll also have that correction history list. Because of this correction history log, any other Aquarius user can also go in and undo or redo any of the changes that we've made to the data set. So I'm going to continue going through this data set and seeing what other data corrections I can make. So let's zoom in on a section here using our zoom in tools. See, we have some spikes in our data set here. If we want to remove those data points based on our flagging results, I can highlight that region and hit delete region due to outlier. Hit again. Now we'll go to the next spike here. And this is actually a spike that was caught up due to our signal trimming toolbox. So I'm going to go to the next spike here, highlight that data point, and delete it again. So now we've said delete region due to outlier a few times. If I want to, I could add that to a list of commonly made corrections, and then I'd have that to use for additional corrections. So I'm going to hit OK here. Now we're continuing. Let's go to the last data point here. And this is our last outlier here. So I'm going to delete that as well. I'll use the list again here and hit OK. So now we've made quite a few outlier trims. We've created a few gaps in our time series because of that, so we can actually interpolate all of those gaps in the time series. So I'm going to set my gap width here, and since I'm sampling at 15-minute intervals, I'm going to say the maximum gap width that I'd allow Aquarius to interpolate is an hour sample. So I'm going to interpolate all of those gaps, hit yes. And now we've corrected for all of those outliers that occurred on our signal. So there's a couple other types of corrections that you can do within this toolbox. We can correct for calibration, drift, and fouling. So this is a prorated by time adjustment because of those two types of errors. You can also do offset corrections where you raise a section, the time series up or down. And again, you can do gap corrections as well. So now that we've done all of our corrections, we can save that data to the output port and exit. And now we have that corrected signal as an output port here. And we can see we've done 11 corrections. So I'm going to bring over my math and statistics descriptive stats toolbox here. I'm going to wire across that corrected signal. Double click on descriptive stats, and this will run the descriptive stats toolbox. So I'm going to expand it here. Here we have the input time series, so this is the turbidity signal in NTUs. And we can compute our stats on the raw signal and the corrected signal. Here's our time series bin, so we can control the to and from dates that we want to perform the statistics for. We can select the full range of statistics. We can look at annual statistics, seasonal, monthly, weekly, daily, or we can set the number of periods that we'd like to look at, or the number of data points. So if we want to look at 1 hour of data, we can set this to 0, 1. So I'm going to check daily data here, and I'm going to hit compute in order to run this list of statistics. So now I've computed those daily values here. So I have the data points, the minimum, the maximum, the sum, the mean. And what I've also done is I've created a couple outputs or time series of those descriptive stats toolbox. So here we have the list of all those outputs that we've created as statistics, and we have the list of statistics here. So we can actually go back, we can add a few more statistics, we can change the outputs here if we wanted to. We can also look at how many of our samples fall above and below a threshold, so we can change this value if we want as well. And I can see how many of my samples fall, say, below 3. So now that I've made a few changes, I can just recompute that. So we can export that table out as a CSV file, so we can export that information. Now when I save that data to the output port and exit, I'll have those 3 time series available to wire to my Quick View toolbox. So I'm going to grab that Quick View toolbox over here, bring that across. As you can see, we have 1 input port on this toolbox. So in order to change the number of input ports that I can bring in, I need to bring up the properties pane and change that to 3. So I'm going to tag that back. You can also bring up the properties pane by right-clicking and bringing up the properties pane that way. So now that I've changed the number of input ports, I can wire those descriptive stats across. Here, double click on that Quick View toolbox, and that will load those 3 signals. So now we have those 3 signals. We can graph those as multiple curves on the same chart by selecting the multiple curve grouping dialog box here. So I can hit OK. Now we've graphed all 3 signals. If we're just interested in 1 month period, we can highlight that region that we're interested in. We can change any of the properties of that chart as well. So I can change my axis information, any of the colors or axis information as well. So I can export this out as a chart image. So I can save that chart image and use that as a way to export out to my report. So I'm going to cancel out of here. Now I'm going to return to the whiteboard. So once we've created this workflow, again, we can save that as an AQW file and save it to use for subsequent analysis.